Everyone. I'm Arlene Baxter. I'm the first vice president of the Berkeley Hillside Club, and it's my pleasure to be here this evening for our November Fireside. This is November 1st, 2021, and it's really an auspicious evening for a number of reasons. This is All Souls Evening, is Samhain for some people, the New Year, and also, it is the beginning of the new administration of our resident manager. Our club members just got to greet her by video. So it is my pleasure to be welcoming this evening a speaker on a very important topic about California wildfires. Let me mention that I'm here at the club. Unfortunately, this evening I'm here by myself, looking forward to future times when we can welcome our membership back. Our clubhouse is a beautiful structure built in 1924 by John White with help by Bernard Maybeck. Bernard Maybeck having been the original architect of this building, and it burned in the 1923 fire. So fire is a very important part of our club's background. Before I introduce our speaker, let me just acknowledge that we are on the territory of the Ohlone people. And with that, I want to introduce our speaker this evening. I'm very pleased to welcome Dr. Scott Stevens with the topic, What's Next? Forest Fires in California's New Climate Reality. Talking about California's frequent forest fires have major problems, and climate change is certainly a factor, but fuels and forest structure are the most critical issues. Dr. Stevens is the head of the Department of Environmental Sciences, Policy and Management on the UC Berkeley campus. He's interested in the interactions of wildfire and ecosystems. This includes how prehistoric fires once interacted with ecosystems, how current wildland fires are affecting ecosystems, and how future fires and management may change that interaction. He's also interested in wildland fire and forest policy and how it can be improved to meet the challenges of the next decades. How fires will be affected by climate change is a new area of research. And with that, I want to give a very warm Hillside Club welcome to Dr. Scott Stevens.
Thank you for the nice introduction, everybody. Thank you for asking me today to talk. I'm very happy to do so. Just hearing about the clubhouse being lost in the 23 fire. At Berkeley, I'm in Mulford Hall. Mulford Hall is pretty darn close to where University Avenue actually intersects the campus.
It's not working.
Well, I hear some echoes back there, but just as a quick mention is Walter Mulford was the first head of our department of forestry at the time. Now we're environmental science, policy and management. His house was lost in the 23 fire too. He lived on Spruce Street. So just about 3 weeks before, he actually donated his personal library to the university. And that was pretty fortuitous because his library collection actually persisted, his house did not. So just an amazing history of fire, unfortunately, in some cases around Berkeley. Of course, we just had the 30th anniversary of the Oakland Hills fire, didn't we? My goodness, 30 years. That was my first semester at Berkeley as a PhD student, of all things. So many of you, I'm sure, have stories and reflections about that fire. So much was lost and personal lives impacted in a big way. So today I'd like to just talk about fire in California, some ideas, and then I hope to get through this presentation 30, 35 minutes tops, and that hopefully would leave them quite a bit of time for you to ask questions and comments. And I really would look forward to that, because I think that's where the conversation really helps just to get ideas forward and enlighten all of us. So that's where I'm headed.
And let me just mention to everyone, if you do have questions, please put them in the chat. I'll be monitoring those. We'll take questions at the end, not interrupt Dr. Stevens in the middle. And we also will have some resources that we will put in the chat at the end as well.
That sounds great. So with that, I'll just share my screen here with a little presentation of just, I got a lot of, I want to share some pictures with everybody, not a lot of, data per se, but I'm going to show some pictures and some experiences I've had over the last 30 years. This is my 30th anniversary working in fire in California, which in some ways is baffling to me. It doesn't feel like it's been that long. But here's just a picture and a slide that says, what's next? Forest fires in California's new climate reality. Of course, we have the United Nations meeting as we speak about climate change. World leaders coming together. Fire seems to percolate into those conversations more and more. So we'll talk about how impact climate change is having on fire. And it is, there's no doubt it is, it's real. But there are some things I think that we can learn from our existing systems that basically allow us maybe to have some hope in what we might actually do. This is a picture right here of a prescribed fire we did probably about 5 years ago in the northern Sierra Nevada. We have a forest called Blodgett Forest. I'm going to show you some research from that place here in a few minutes. But you can see fires burning in the understory, consuming a lot of accumulated surface fuel and other materials. And that idea of burning, getting fire back on the land is certainly being discussed in a lot of ways. Governor Newsom talks about it a great deal. Secretary Crowfoot, Secretary of Natural Resources, California, Tom Porter, Director Cal Fire. I mean, it has changed. In the last year, the Brown administration through the Newsom administration have really been transformative in the ideas of fire in California from the state level. And we'll talk a little bit about that too. I think what they're doing right now is very great. I just wish it had started 30 years ago. So I just want to show again a couple photos here and give us a sense of just some ideas. So this turns out to be a little house actually built in 1915 by a early U.S. Forest Service guard in the Plumas National Forest. The Plumas National Forest is up there in kind of the northern Sierra Nevada. And here you see a guard station built in 1915. Of course, the Forest Service was created by Congress in 1905. This is just 10 years after the Forest Service creation. And shortly after, people started to think about fire and forest, and there was this two people, Sho and Kotak, and they were early scientists working for the U.S. Forest Service. And they wrote several publications. And here's one in 1924. Here's a quote from it. California pine forests represent broken, patchy understock stands worn down by the attrition of repeated light fires. And then, let me see here. Extensive crown fires are almost unknown to the California pine region. So a crown fire is when a fire burns in the overstory and the understory simultaneous. So you basically combust the overstory, the tree canopy, the leaves, the needles of the tree, and you actually burn the understory. But here they're saying in 1924, extensive crown fires are almost unknown to the California pine region. That's kind of a startling statement if we think about where we are today. And then what we have then for kind of contemporary issues is what about today's forests? And there's a lot of fires that have happened in the last 10 years, 5 years, 3 years. One I'm going to show you here is the North Complex fire, just as one I wanted to talk about. That was one last year. We had that big lightning bust. All those lightning fires started simultaneously, including the CZU Complex fire, a multitude of fires that were burning in the state. This was one of those. It ignited August 2020. It was 2 ignitions, remote area, so it was prioritized very low before suppression resources actually started to work on it. There are a lot of other fires in California near more people, more resources. They are prioritized higher. But eventually, unfortunately, a terrible east wind blew, and the east wind took the fire from kind of up here in the upper region and blew it downhill. And maybe you see down here to the lower left, that's Lake Oroville. So that's Lake Oroville right down there in the bottom. Of course, Lake Oroville is the largest reservoir in the California State Water Project, the largest by far, okay? This fire, I don't know, I bet you a lot of you do remember, in August, it started, but then shortly in September, we had a big push. Maybe you remember that day when you went outside in the Bay Area and the sky was orange. I don't know if you remember that day. I still remember it. I was outside walking my dog, just taking a little stroll around, and I looked outside, and the sky was kind of an orange red. It was just very, very, very odd. Turns out this big red patch that burned is actually the emissions that created that orange sky in the Bay Area. That big red patch we call high severity. That's over 75 to 100% of the overstory trees were killed by the fire by that big giant run. That was only about 8 hours, about an 8-hour run. And it burned that whole area and put all that smoke in the atmosphere. The smoke was transported to the Bay Area, interacted with the fog of the Bay Area, and created that red-orange sky. Okay. Unfortunately, 16 people died in this fire. It was at night, burned around 318,000 acres. And then we have this huge high severity patch that's mapped from remote sensing. The problem with that patch is all the trees of the Sierra Nevada take about 2 years, most of them, to develop a cone that's ripe and producing seed. So after that 2-year process, the cone opens, dumps the seed out to the soil, and it's moved around by small mammals and other things, and we can get regeneration, of course, from that seed. But the seed only lasts about 4 months, 3 or 4 months, it's viable. After that, it's gone. So when you have a fire that has this much intensity, that much heat over such vast areas, what you do essentially is you take the seed source of the trees, you eliminate it. The cones are not closed like Yellowstone National Park. A lot of you have been to Yellowstone. You got lodgepole pine with a closed cone. Fire heats that cone, opens up, dumps seed afterwards. The seed survives a severe crown fire. California, Sierra Nevada, we have none of those species. All of our species open their cones when they're ripe. The seed is dispersed, so they really are effective at very short distances. A couple 100 feet, that seed can move and you can regenerate a site. But if you have a high severity patch like this, I was just through this on last Sunday again. There are places in here you can walk for miles and you cannot see a live conifer tree. Miles and miles. That severity patch is really going to cause what I would call a type conversion. Most of that area is going to go to shrubs and hardwoods like oaks, and the conifers just simply will have a very difficult time to ever regenerate. This was considered before the wildfire critical old growth habitat for the California spotted owl. In fact, I think there were 86 potential nest sites in this area. Not all 86 were burned by the high severity, but some were, quite a few were. So that's a conundrum we really have in California in a lot of our forests. Too much mortality continuous, which then really sets the stage for a type conversion to a non-forest condition. Things like water quality. What's going on with Lake Oroville when we had 12 inches of rain up here in the last 48 hours, that last weekend? What's going on with carbon sequestration? How much carbon is being sequestered? How much is being emitted? What's going on with aesthetics? What's going on with wildlife habitat? There are so many things that are going on in that landscape that a fire like this causes great harm. The areas up here to the north, you see they're a little bit more diverse when you had smaller patches of high severity, and the greens and the yellows show us where the forest survived. Actually, the areas in this area are restorative. The fire really did restoration. Okay, it did ecological good. But the problem is you had to pay an enormous price for that restoration. This huge area of high severity that was created, 16 people dead, and I think almost 800 houses lost. So that's the conundrum we have, is how do we try to have resiliency in our landscapes and not really create these conditions where our forests are really stressed to a point where we can't maybe not even regenerate them. So what are we going to do about it? Well, here's some of the good news, okay? Now we're back to Blodgett Forest. Blodgett Forest is a slide on the first slide of my presentation. But I want to show you some pictures from a research study we've been doing for 20 years now. So this is a beginning point, 2002. You see the picture there, 2002. And what we're going to do is we're taking an initial condition right here. This is a place that has not had any burning for 100 years. It's had 3 harvests in the last 50 years, harvest for saw timber. We have fire history from tree ring analysis here. This place used to burn every 7 to 15 years until about 1898, all fire stops. It stops because the Forest Service starts putting fires out, and also other institutions. So it burns every 7 to 15 years, 1650 to about 1900, and then doesn't burn at all. What do you see? You see a lot of dead and down fuel in the ground that's accumulated. You also see high numbers of trees that have regenerated and grown. Those trees now are basically trying to make a living in a very crowded condition. This is a very typical condition of a mixed conifer forest almost anywhere in California. Southern California mountains, the Klamath Mountains, the Sierra Nevada, the Coast Ranges, you pick your place. This is probably 300 trees per acre. The surface fuel, the dead and down woody material we see on the ground, is 30 tons per acre, 30 tons per acre on that forest floor. And this is a condition that's very vulnerable to that high severity patch I just showed you. So we're going to do some restoration here. First, we're going to use just prescribed fire, the idea of actually burning this forest to try to begin some restoration. I want you to keep your eye on this large sugar pine dead center. You're going to see that in the repeat photographs. So the first picture is actually a picture of the burning. So this is our burning on that particular area in 2002. You can see it's at night. We did it at night because humidity is high, temperatures are low. It's a good weather condition to burn in. You're always interested in the weather when you're doing fire. That's the one thing that always causes potential challenges because the weather can change so quickly. I've been on so many fires where you'll see the fire behavior change right in front of your eyes, literally in minutes because of weather change. So you're looking for the weather that works for you. And one thing maybe you can see in this photograph, look at all those sparks. Look at all those sparks above the fire. Those are basically pieces of material that's being lofted outside the fire line. Many of those sparks will drop down in areas outside of the fire line. And they don't start fires because relative humidity, maybe it's 50%, 40%, 60%. That relative humidity is just enough that you have just enough fine fuel moisture that's high enough when those embers come down and touch on that unburned area, it doesn't start a new fire. Get down around 25%, high 20s, you got enough potential then to dry that fuel that those sparks are going to start fires all over the place. So you're really interested in relative humidity when you're burning anywhere in California because it's such a powerful piece. So after the fire, there's our tree. Okay, there's that sugar pine. And you say, wow, look there. You know, we've actually consumed about 85% of the surface fuel. Okay, that's a good thing. And we actually killed about 75% of the trees below 12 inches in diameter. That was the goal. Tree density is too high. So we're using fire as the tool here to actually start that transformation. So we're killing some trees, a lot of smalls. The big tree in the center, you can't see its crown, but it's still alive. So let's go forward. This is 2003. Here we are 7 years later, 2009. And you can see what's happened. Well, some of those trees that we killed in that first fire are starting to come down, okay? They're starting to rot, starting to decompose. The wind and the snow are knocking them down, just like you would expect. We also see a shrub starting to grow here in the foreground. That's Ceanothus integrimus. That's a native Ceanothus in the Sierra Nevada. So it's kind of a transformation from that initial picture to now. What are we going to do about it? Well, we're going to burn it again. So here's, I remember being here and I had my drip torch. We were igniting this unit again, took my camera out, took a picture of actual same spot I just been showing you. You see the burning going on in the foreground. Next picture is right after the second prescribed fire. And you can start to see, wow, the place is starting to change, isn't it? Now all of a sudden you can see back there a couple hundred feet, still some logs in the ground, surface fuels reduced, some shrubs survive, a little bit more heterogeneity here because of the fire behavior. So this is after the second fire, 2010. Let's go forward again, another 7, 8 years. And there's more of that material coming down, both from the first and the second fire that have killed the small trees. We see the shrubs are basically starting to regrow again. This is succession or changes in plant communities over time. So what do we do about it? We burn it a third time. So here's the third ignition in 2017. And right after that ignition, this is essentially what the forest looked like after the third fire. And a picture I just took a few months ago, this is what it looks like today, 2021. So I would just say at the end of the day, this is a very desirable forest structure from a fire, climate change, and bark beetle kind of idea. So we have modeled now this particular forest in this condition, even under a severe wildfire condition, you're going to keep 70% of the overstory trees are going to survive. You're not going to lose the overstory. You're going to keep that overstory intact, keep that seed source viable, so the forest will be able to regenerate. And we actually are working with 3 tribes now in California. One here, we're just beginning to work with the Nissan. The Nissan are the Native American community that home range overlaps Blodgett Forest. And when you talk to Native communities, including the Ama Mutsun near Santa Cruz, also the North Fork Mono, which is on the foothills in the Sierra Nevada to the south, one thing that the Native people will tell you is they actively steward their lands. They manage those lands for many purposes: food, cordage materials, basket materials, medicine, spiritual. It is an active participation. There's no hands off. Okay, so when you talk to Native people, and I've done this now for years, I actually teach a class right now at Berkeley to bring in Native scholars to a class, a lower division course, Fire and Culture of California. They all talk about active stewardship and their engagement of that stewardship actually commanded by Creator. So that's something we have to learn from. We've not stewarded our lands like we need to keep the fire behavior potentially lower and the ability then of these systems to basically persist. And we need to get back to using some of these techniques to steward the land, just like tribes continue to do so and did in the past. And that's something that I think I've learned in my career at Berkeley. Let's look at another set of photos here. Now we're going to do something a little different. We're not going to use any fire, no fire at all. We're just going to use machines to do a restoration. This is another one of the treatments that we wanted to test up here. We're doing a restoration thinning treatment, okay? Same general area. Here's an initial condition. Same condition I told you, about 300 trees per acre, 30 tons of surface fuel on the ground, hasn't burned in close to 100 years plus, used to burn every 7 to 15, both by the Nissan people and lightning fire, both of those types of fire. So now I want you to watch this oak over here. This is a California black oak up there. You see a little arrow to it. That's going to be our vantage point for this sequence of photographs. So the next one shows the masticator that we came in there and actually did a thinning treatment. We took trees out. And the one thing that's so important when you do a restoration, you actually are concentrating on what you want to leave, and then anything in excess of that you want to remove. We wanted to leave trees with larger diameters. We wanted a species mix, maybe increased pine dominance, because pines are better for things like climate change and fire. So you go in with the attitude, you want to think about what you want to leave, you leave that, and then anything that's outside of that, you remove the machine, okay? So it's not a timber grab. Sometimes people will call this a timber grab. It's not. I've worked on this for 20 years. It can be a timber grab, but that's your objective. You go in there and you want to maximize yield. You want to maximize growth. You want to grow timber. There are private companies in this state that do that. They do it with the forest practice rules. But that's not what we're doing here. We're actually going in there with the idea, what do we want to leave to try to persist a forest into the future with climate change, fire, bark beetles, and others. So here's what it looks like after that first treatment. And there you see that California black oak still leaning in. You see an awful lot of material on the ground. Okay, we're not burning this. We didn't ship it to make bioenergy. We didn't make biochar out of it. We really need more ability to use this material in an economic sense. Eventually, this material does decompose, but before it decomposes, you really are in a condition that's relatively high hazard. Okay, so let's take a look now at a few years into the future. 2003, here's 8 years after the first treatment. And you can see, wow, that material is starting to grow in the understory. Actually, by the 8th year, 80% of the material that was on the ground that had been masticated had decomposed, just decomposed by fungi with no fire at all. And now we go a few more years into the future. We see that the trees are regenerating in the understory. This is 13 years after the first treatment. Trees are coming back. They're reseeding. They're getting established. So what are we going to do? We're going to do a restoration thinning again. And here's a second restoration thinning that we did in 2019, just after the treatment. We took some trees out again. We did the mastication to reduce the shrub height and the regeneration of conifers. And if you look at the site today, this is what it looks like in 2021. So at the end of the day, this is also a very effective treatment for many purposes. It doesn't duplicate fire. It doesn't completely duplicate the process of fire. It does not recycle nutrients the same way, does not put smoke into the canopy, which can change things like entomology and insects. But it does do some things like reduce forest density, reduce the surface fuel. And then when we model the fire behavior of this condition under a severe wildfire, we're still going to keep around 70% of the overstory alive. It turns out this one sequesters the carbon the most. This one is sequestering more CO2 out of the atmosphere than the fire treatment did, because the fire treatment, of course, damages the trees in all the area that you basically burn, where here we didn't have that particular input. So I'm not saying this is better or worse than fire. I'm just saying it's another one you could consider. And from a restoration standpoint, we've done nice work here in 20 years. This is a nice outcome, okay? So that's one sequence of kind of ideas that enable us to do the work we need to actually try to combat the impact of climate change. Let's go to Yosemite here for a minute. I want to show you one more sequence of photos so we can get to your questions. Illilouette Creek Basin is down here in this little shaded area. That's actually a watershed, the upper Merced River. Of course, the Merced River goes right through Yosemite Valley, doesn't it? So this is one area of Yosemite that actually the lightning fire regime has been reintroduced since 1972. And the pictures on the right show where a fire is burned through a Jeffrey Pine mixed conifer stand in Illilouette, and down below another one. And here's kind of a set of fire perimeters. Each of those different colors is a different fire that's burned in Illilouette since 1972, all lightning ignited. Some of these fires have had some suppression, but the vast majority have had basically free burning. And if we go look, here's a photograph of one of those fires. It's a little bit higher elevation than we were at Blodgett. This is mostly red fir, white fir, Jeffrey pine, lodgepole pine, quaking aspen. That's the Hoover Fire 2001. And here's a picture of a high severity patch that was killed by the Hoover Fire, but you also see lodgepole pine regenerating in the patch. The median patch size of high severity inside Illilouette is 10 acres or 4 hectares. So it's about 4 hectares, 10 acres. Most patches are less than 1 acre in size. The largest patch was maybe around 150 acres. Really amazing, kind of highly heterogeneous condition, patches of high severity occurring, the vast majority underburned where trees survive. And these patches actually regenerate because they're close enough to a seed source, a live tree. Yeah, and this basically is a patch of the Illilouette Creek. Some people look at that and say, that looks awful messy. You know, look at all these dead trees standing on the ground. I've had a lot of people out here over the years. In fact, it's very easy to get to this site. All you got to do is the Mono Meadows trailhead on the road to Glacier Point. You walk in there about 2 miles, you're into this. Okay, it's not hard to get to at all. But Illilouette Creek has been an amazing place for us to work. And here's a couple of things I want to show you. Here's 1970. In 1970, the National Park Service was just as good at putting fires out as the Forest Service. They started putting fires out about 100 years earlier, and the culmination of that is all this green. The green is basically forest condition from aerial photos. The gray is rock, and then the brown is shrubs. Over here on the right, you see the same place, but 2012 after about 40 different lightning fires. And what's happened? Well, the forest area of this particular site has been decreased by 22%. I'm not talking about the forest has been thinned. You're talking about changing a forest to something like a shrubland, a grassland, or a wetland. And you see down there at the bottom, what's happened. You've had amazing changes where wet meadows have increased by 200%, dry meadows have increased by 200% in 2012 because of the reintroduction of fire, and the shrublands have increased by 30%. So you've had this transformation from this landscape on the left to something that is probably as close to anything that is quote unquote under a natural fire process anywhere in the state of California. That's an amazing place to visit. It's actually, I think it's quite beautiful. And there's a couple other things I want to show you, and then we're going to take some questions. I hope you have some questions. What about water? We all know that water is big in California. I think it's the most important natural resource in the entire natural ecosystems of this state. I think it's only going to get more important as decades go forward in climate change. Well, Illilouette Creek is part of this picture. It's the blue little perimeter that you see down here. All this pink is wildfires. So you can see Illilouette Creek's got a bunch of those small wildfires we just talked about. And over here outside the park, you see these other polygons that are kind of purple. Each of those is an area about the size of Illilouette Creek, about the same elevation, the same soils, the same vegetation, but they've had no fire since about 1900. But Illilouette, of course, have had all those fires. We've had some great people working on this with me from civil engineering at UC Berkeley, Gabrielle, Katia, and some others. And we find out that the amount of water leaving Illilouette Creek since 1972 as stream water has slightly increased over that period from 72 to the present. We call that the runoff coefficient. All these other places that we did the analysis on based on stream gauges, this is not a model, this is actually stream gauge data. Every one of those things significantly decreased. So the amount of water leaving Illilouette has increased by 60 millimeters roughly. That's about 2 inches, about 2 inches more water over the entire watershed. That's quite a bit of water, not a huge amount, but it's quite a bit. Whereas all the other places have significantly decreased in their water output per unit water in. We also know that the amount of soil moisture in Illilouette is increased, and that actually reduced the damage or mortality from the 2012 to 2015 drought. Less than 10% of the trees died in Illilouette compared to outside. And Katia did an analysis of this into the future with climate change. And actually this watershed benefit is robust to climate change for the next 50 years based on an analysis she did and wrote a paper. I would say, again, this is some good news. Some good news that maybe water connected to forest resiliency, connected maybe to wildlife habitat, having this ability, even in a changing climate, this system is working. We see no trends in higher severity fire in this basin. We don't see any trends in increased fire size. This system is working when fire is working with it. Powerful example of potential. So I think I'm just down to the last couple slides. California frequent fire forests are in trouble, and climate change is a piece of it. Climate change makes an existing terrible position worse. It's not the majority. My estimate is the climate change impacts of this system about 20 to 25%, 80 to 75% is the forest structure, the stuff we just looked at. You get that forest structure in a system that actually is a little bit more aligned to what you need for the future, those forests are going to persist even with climate change. There's no doubt climate's going to stress them and do some other things that are unforeseen. But climate change is not the main factor of the systems that we're looking at right there. Okay, what do we need? We need more prescribed burning, restoration thinning, indigenous burning by tribes, and maybe managed wildfire like they do in, I showed you in Yellowstone, in Yosemite. It's a bumpy road, but what's the alternative? The alternative are things like North Complex Fire, the Dixie Fire, the Caldor Fire. I could list these things off. I can't even remember their names, or so many of them anymore, okay? It just tells us we are really in a position now, we have to do decisive change. CAL FIRE has moved with the state government more decisively. We got this idea of 1 million acres treatment per year restoration by 2025 by Newsom and the chief of the Forest Service. California Assembly and Senate, they've done some really good work there in the last 3 or 4 years, including this year, passed bills that are going to make a difference. US Congress, I've been working with Dianne Feinstein's office for several years on a bill. They're working on this. Biden and Harris administration haven't really ruled into this yet. They basically had other issues, I know, but they haven't probably got into this world. So I would just say there is hope based on some of the things I've shown you about how we can live with fire more sustainably, but it's going to take decisive change. It cannot be what we've been doing. My back of the envelope calculation says we need to do 10 times more restoration, prescribed burning, restoration thinning, managed wildfire than we're doing today, 10 times. And you know what? We learn from the tribes, we do it forever. This is about stewardship. This is about keeping these systems in better condition. It means we never get off the conveyor belt, never. I know that's a challenge. That's exactly what we have to do. And I'll just thank a few folks that have helped me along the way here. And maybe there's some any types of comments or questions, I'd be happy to hear them. Thank you.
Thank you very much, Dr. Stevens. I also want to thank you for your notes of optimism and encouragement that there are things we can do, and especially mentioning the active stewardships, recognizing that our land and fire are gifts from the Creator, and that we have an active role to play as stewards to manage the land. So with that, there was a question in the chat that I'll start off with, which was to ask if there were any Siskiyou area Native tribes that are also partnering in work on forest management.
You know, there are a bunch of very active tribes in the Northwest California. You know, that particular region, you know, I probably don't, in my mind at least, and I don't know what's going on all over the state, but if you look at the Northwestern tribes, you know, the Northwestern tribes are some of the most active tribes in the state. So I think there are centers of tribal kind of innovation and work that are happening across the state. Another thing happened this year, maybe you saw it, Governor Newsom signed a bill that actually said the state government is going to effectively partner with these tribes in fire and sustainability. It's not going to be a one-way road anymore. It used to be the tribes would get a letter from the state asking for comment, asking if maybe archaeological site was going to be damaged or something like that. This is supposed to be true partnership, and they actually just created a new position in CAL FIRE, in the administration of CAL FIRE, a cultural fire liaison. Never happened in the history of the state. That was signed by Newsom about 3 weeks ago. So there is really a point now, I think, where tribes, if they choose to, can work with the state. Of course, they're sovereign nations, it's up to them. But I think that there is this more really interest in this going forward. The federal government has not done these types of activities and probably needs to also get on board. But I'll give some credit to the state and some of the legislative process here.
That's encouraging, very absolutely. Another question for you, are there animal species that are part of the forest management process? Many kinds of birds and dead trees use dead trees for nesting and for food. but we're wondering about, especially about beavers, who can significantly modify the landscape for the better.
Oh, you're absolutely right. You know, when you look at that forest ecosystem, and you're right, you know, dead wood is not something that is basically not needed in the forest ecosystem. We need it for many wildlife species, including birds, even insects. So you think about that and the idea of trying to create that mosaic that maybe Illilouette is actually created. We had one really interesting study that happened at Illilouette by a scientist, a biodiversity scientist. She went in there named Lauren. She's at the University of Oregon now. And she went in there and sampled the pollinators on the native plants that were actually growing after these fires. And she found through her analysis that the areas that had higher pyrodiversity is simply the idea of having more variety in fire regime, small patches of high severity, other areas under burn, some places maybe completely missed. She found that the places in Illilouette that had higher pyrodiversity had the highest native bee populations. And another thing that was really fascinating, when the drought came on top of it, they actually were able to move to different floral components that had resilience during the drought, and they maintained their vigor. So this was a really fascinating study that she was able to do. It just shows the intricacies of this wildlife. And we're doing bird work out there. We're also sampling bats, trying to understand the bat populations of beasts and species. And there's one thing for certain: when you change a forest, some species will benefit, others will not. Okay. But the question is, can you do it maybe in a way where the sustainability of the system basically is over the long term might actually allow those populations to persist? But a good question about wildlife, and one that's not easy to answer.
But the answer that you gave was encouraging, at least. So another question is understanding, was it too high a density of trees and shrubs decreases how much snow stays on the ground, which reduces runoff too, as well as the trees being stressed for competition for water? Any comment?
No, you're right on the money. You know, Sally Thompson, who was a professor of civil engineering at Berkeley, now she's moved actually to the University of Western Australia, where she came from. But Sally did a lot of work with us on snow and the physics of snow. The physics of snow is fascinating. And just like you alluded to, if you have a forest with a big canopy, a lot of that snow is going to be intercepted, also rain. And then some of that snow is going to sublimate to the atmosphere, never get on the ground. And the rain would, some of it could actually just dry and go to the atmosphere. So having these smaller patches of opening allows the snow to accumulate. Shade from adjacent trees can actually keep that snow for longer periods. And just like you said, you also have less biomass taking water out of the system. And that leads to more water available in the soil and more water going into streams. So I think you're right on the money. And I think that's one of the things that I'm most excited about in Illilouette, showing that there is a connection to hydrology, connection to water resources. And I worry that, like that fire I showed you, North Complex, it burned the middle fork of the Feather River with that giant red patch. That's the largest river of the middle fork into Lake Oroville. How's that going to change water quality and quantity? There's no doubt you're going to see increased erosion from that system. So these connections to water, I think, are just paramount. And it's something I think the state is starting to look at even more.
Another question or comment: a private landowner in California with forest lands listed in the National Registry told me that it took almost 6 years and $18,000 in professional services to get permission to clear ground fuel on his own land just prior to the recent permit consolidation. How long now would it take? Evidently, a person said in humor, would take 4 years now instead of 6.
That's a good question. You know, when you look at private forest lands and state forest lands, if you have commercial species, that means, you know, trees like ponderosa pine, white fir, incense cedar, Douglas fir, a lot of these species, then the California forest practice rules are in play. And that means if you want to do something that modifies that system, at least if you do something that's over a threshold, you need a licensed professional forester to write a plan for you. And that talks about that money you just talked about, $10,000 or something like that. And it takes some time, maybe a couple of years to do that. But the state is actually doing a few things now to try to alleviate that. They're actually saying if you want to do a fuel treatment instead of maybe a commercial application where you're going to harvest saw timber and sell it, but more maybe the idea I showed you of a restoration. You can still take some trees out, but not as many as maybe in a commercial. There are actually systems in place now that allow that to go much more efficiently. And we do have a California VMP program, vegetation management program, systematic EIR that just got finished and published by CAL FIRE that allows people to tie into that and actually try to do more efficient planning, because the document gives you some connection to some of the work you want to do. You don't have to go through all the grueling kind of procedures. But you're right that there are procedures that still have to be followed, but the California Forest Practice Rules and CAL FIRE and the State Board of Forestry are trying to streamline that for small private landowners. Larger landowners are still going through that system.
Well, of course, all of us, even in the Bay Area now, are getting used to the new fire hardening rules requiring clearing of brush around our homes, with some real serious implications if we don't, basically of not being able to get insurance.
That's right.
So we all need to be more keyed into the trees, rather in our own yards or in the forest. See, another question, what is the impact of new community development into these forest areas and difficulties of using your suggested techniques of control of these densely forested areas?
No, it's another really important. I think there are really two fundamental things of making our systems more resilient to fire in this state. There are two things we got to do. One is, which your question's on, is getting people better prepared for the inevitability of fire, including new construction. When you look at the way we have our housing stock distributed through this state and kind of some of the areas that it's in, you know it's difficult, okay? And that's just really a fact. And we need to do less of that as we go forward. Of course, counties want building to happen because of things like tax receipts and revenue. But I would say, you know, I've been in Australia a fair amount and worked with the Australians on this. One thing the Australians do, I think, better than us, is they get people that live in these areas inside the wildland urban interface, both more in the conversation of what it is and actually in potential solutions. They do things like community fire brigades, where people get organized at the community level, a lot like some of the groups that you know, Claremont Conservancy and others. And they basically come up with plans at community scale. They say things like, well, I got a neighbor that's actually 85 years old, doesn't have a car anymore. If we have a fire in here, you and I are going to make sure they get out. I got a person down the street, they just had a baby. They're not going to be very mobile. I got a couple other people that are very mobile and they can do this. And in Australia, the fire service will come out and actually have a conversation with the homeowners about this. It's all volunteer. And if you go through some training, they will leave a trailer of fire equipment in your neighborhood. Inside that trailer is radios, fire hydrants that you could connect to fire hoses. And it is a full kind of setup to do some work in your neighborhood. We don't do that in California for a lot of reasons, liability and some other things. But the other thing that I think we have to do is get our communities better prepared at that level. And one thing that you can do is University of California, many of you know, have cooperative extension. Cooperative extension is a branch of the university that's county-based. It's not campus-based, it's county-based. And there are professionals in all counties in this state that work in cooperative extension. One of the biggest is agriculture. Salinas Valley, San Joaquin Valley, Sacramento Valley, Napa Valley. There are people there that work with people that are actually doing that farming, new ideas for cultivars, different ways that you can irrigate. It is a magnificent system. I think it's time to do that for fire in this state. We should have a cooperative extension network of folks that are on all the counties, San Diego, Modoc, Napa, El Dorado. It's all different fire issues, different populations, but have a person that could be there and be the focal point to have those conversations. Actually, we're doing a little of that. The legislature put $2 million to increase that this year, which I think is good, but I think that's one thing we can do. The other thing we have to do is get our ecosystems better prepared for fire, climate change. Okay, that's the stuff I showed you before. If you don't change those fundamentals, our ecosystems better prepared and the populations that live among them and next to them better prepared, we're going to chase our tails forever. There's no reason it's going to get better.
Right. One of our questioners says you make a great case for better and more active management of forests. We're failing woefully short of reaching the goal of 1 million acres per year, and we are only putting in about $200 million a year to reach the goal. How do we make this more economically viable?
Yeah,
How do
you're
we
right.
deal with permitting challenges?
No, you're right. I agree with you. When I look at what's happened, in the state, in what we call the state of California today, and my predecessor at UC Berkeley, Professor Harold Biswell, he got here in 1947, and his career was till 1972. He was the first professor of fire west of the Mississippi River. Biswell published his first paper on prescribed burning and forest problems in 1958. In there, he basically foresaw what we got going on today. So Biswell, after that number of years of work, he worked in the near Middletown in Lake County, a place called Hoburgs, a little small place. And he also worked in the southern Sierra Nevada near Bass Lake, two places that were privately owned because the Forest Service and any federal agency refused to work with Biswell. He thought he was crazy. So Biswell worked in these private areas. And then after working about 7 years, he wrote that paper in 1958. He compared California forest to Georgia forest. Turns out the Southeast is a prescribed fire center of the United States of America, continues to be so today. Biswell learned about that during his time working in the Southeast for the U.S. Forest Service Research Station. He came to California and tried to implement some of those ideas in California. So you're right. When you look at just the scale of the issue, it's daunting. It is, and it makes me very nervous. And then you think about climate change also impacting these systems and things like a 2-year drought. Hopefully that drought's over. We don't know for sure, but that 2-year drought was also a big issue. So the vulnerability of our systems is extreme. And I'll give credit to the Newsom administration, some of the folks at state level that are trying to push this. I wish it started 30 years ago or even longer. I wish we thought about the tribes as more partners versus somehow groups that need to be marginalized, which is what we've done for history, right? So I think we are at a point where we're really at a crossroads. I think we got 10 to 20 years. 10 to 20 years, either we're going to change this a little bit and get it on a trajectory that's more favorable, or it's going to change right in front of our eyes, and we're going to be spectators the whole damn time. So I would say that, that's my view. Some people call me a little bit of an alarmist. I don't think that's true. I'm not an alarmist at all. But I do think when I see that there's opportunities to make a difference, that's when I get a little excited. Okay, and that's when I've been trying to work with Feinstein's groups and others to try to move this forward. I think we probably need some policy change at the federal level to help this out.
Well, that's a good segue into the other part of that question, which is, do we have the political wherewithal to make these changes? And I would put the question to you, what would you suggest to our individual viewers and anyone who listens to the recording of this? Who do we write to? What is going to be the most effective things that we as citizen activists can do to make a difference?
No, I appreciate that. I do think, and this is hard. Okay, this is hard. I've been, through my work at Berkeley, I've been able to give testimony 3 times to the U.S. House of Representatives. I gave testimony to the White House when Joe Biden was vice president. That's when I did that, the last year of the Obama administration. And when you think about this, I think my view is we need to be a little more bold, okay? There are initiatives in Congress that have happened over the years, and it's almost like take our system and just make it a little better. Let's make the planning process a little more efficient. We know we don't plan fast enough. We spend too much time, too much money. Let's try to reform that. I think we got to think a little bit more boldly. My idea, and this some people think is crazy, but if you look at federal policy that impacts forests, you got some powerful legislation. Clean Water Act. Clean Water Act is a powerful piece of legislation. It's changed water through the lake states and a lot of places. The Clean Air Act. The Clean Air Act has had a profound impact to California and the Western US. Used to be smog in LA Basin was awful. It's actually better now, okay? Endangered Species Act. Endangered Species Act, another powerful piece of legislation. Bring the condor back from the brink of extinction, many other animals, right? But you know what? How do you have clean air? How do you have clean water? And how do you have a sustainable wildlife if you don't have a sustainable forest? So my view is, I think, and this is where people think I'm crazy, I think we should have a Forest Resiliency Act. I think you got to have an act in law that actually says this is important. And you know what? Maybe even more important than those other 3 I just told you about. Because what happens today is when you look at clean air, clean water, and also endangered habitat, and you put that into that system, you come up with this muddled idea of what we can do. And frankly, from a fire perspective, you know what? In California, it hasn't worked. That's what I'd say. So that's my kind of grand idea, something that might focus federal land management to actually try to put that resiliency of these systems at a higher capacity and try to move that forward. Of course, some people would totally disagree.
Well, and wouldn't we also have to revamp the EPA at this point as it
Yeah.
has devolved? But that's a topic for another evening. Um, Couple more questions before we go here. How do you feel the small Eastern Sierra towns volunteer fire departments are
Mm.
doing in general?
I think volunteer fire departments are powerful. I know several personally. Meadow Valley Fire Department is right next to our UC Berkeley Forestry Summer Camp. That's in Plumas County. And you look at volunteer firefighters, that's a dedicated bunch. Okay. They work, they actually have jobs, they have to do training to get trained for their activities to be a volunteer fire department. And I think that they're just one of those things of what we are as just a powerful force. I do think they probably need some help. Of course, they have to get engines and get the training. And I think that they're still very, very powerful. And no doubt the fire departments are a piece of this. Be nice to see some of the fire departments have the chance to be proactive, do some of that prescribed burning we're talking about, some of that indigenous burning we're talking about, maybe work with some of the tribes, work with some of these other systems. Because one thing is for certain, if we just focus on putting fires out as we have for the last 100 to 150 years or longer, in many ecosystems, our problems persist and get worse. Okay, so it doesn't mean we need burning everywhere. I wrote this paper in 2007. We estimated 4.5 million acres burned in California on an average year and 12 million burned on a big year. So about 4.5 to 12 million acres. 2020, we burned 4.2 million. We got pretty close to that number, the first time in our history. That's just a number that gives a sense of just how much fire used to be in this state. Indigenous burning was probably at least half of that. Lightning fire, the other half. So it just shows just how important fire was. Harold Biswell, my predecessor I told you about, he had this saying, fire was almost as important as soil and rain to the vegetation of California. Almost as important to soil and rain. And we've lost that. Of course, the tribes never lost it. They basically have used it as one of their prime sources of stewardship. So I think there is the volunteer fire departments and organizations, they've stood up, they're powerful, but I think we got to get more proactive in everything we do.
To just take one more question, which was, are there water districts willing to pay to treat forests on the assumption that more water will reach reservoirs, or to reduce sedimentary into reservoirs when catastrophic fires occur?
There are some of these changing. Maybe you remember a few years ago, Denver Water and Power, when the watershed of Denver, Colorado burned in a severe fire, Denver Water and Power all of a sudden did an amazing pivot and started to actually do real investments into watersheds. I think in California, we're on the cusp maybe of that happening. I've talked to a lot of water agencies. One of the big fires that we had a number of years ago was just outside Yosemite National Park. It actually burned in 2013, right? So that was a giant fire, one that at the time really got our attention, the Stanislaus National Forest, and also it burned in Yosemite. The first organization that actually started to call the Forest Service about that fire because they were worried, San Francisco Water and Power. They own Hetch Hetchy, right? Look what Hetch Hetchy is. Big giant reservoir, generates big revenue for the city and county of San Francisco. But the rim fire had burned into that area. They were the first ones to worry about it. And to their credit, they do put a little bit of money into the watershed maintenance and management of Yosemite, but it needs to be much larger. I think this is one place that you could actually do something innovative and maybe have the agencies that manage our water and provide water to us get actively engaged in that management of that watershed. Right now, they don't. It's really almost like the water just comes downhill, okay? And I think that's something that really is not going to work into the future. When I talk to these boards of water, I've done this a little bit in my career, you say, this is a great idea. We want a water bond. We want the voters to pass a water bond, and let's do that with bond money versus let's not do it with actually costs to our organization that we have to pass on maybe to our customers. I think that's something that needs to change.
Final recommendation of what we as citizen activists, is it right to Feinstein? You're already in touch with her.
I think Feinstein really is someone that through her career has worked in this area. She really has. I don't know if she's going to run for re-election or anything like that. And she's going to be up in 2024, okay? Not in 2022. But I do think writing to her is a good move because I do think that this is something that she's taken to heart. I've talked to her staff, and this is something she's very interested in. I don't know the other senator very well of California. I wonder what he thinks. Maybe some of you have connections to him or his office. I don't. Be interesting to see if that our second senator, and forgive me, I don't remember his name. I bet you some of you know, but it'd be interesting to know what the second senator of our state actually thinks about this. But writing to Feinstein and to him, I think is a pretty darn good idea.
Idea.
Yeah, there you go. Thank you.
Thank you. Yes. Well, with that, I'm going to say a couple of things. I put a couple of notes in the chat. One was to Professor Stevens' TED Talk from 2019. And there's some additional information there also about use of helicopters and various other technologies. Brian Hamlin has put together a link of a number of articles, both from Dr. Stevens and others, on fire management. That's also in the chat. Just so you know, this has been recorded and will be posted within the next few days on our YouTube channel, along with a link to the interview that I did with Ellen. Before I say goodnight, I just want to share one more thing with you all. Since this is Samhain, it seemed appropriate, and in recognition of our connection tonight with a thinner veil to those who've gone before and the recognition of some people in stewardship of the land, I'd like to read you a poem that was written by a friend of mine, Lynn Unger, within the dance community, called Samhain. Set an altar for your beloved dead. Put out food and drink, flowers, the delights of the living. Gather at the table. Tell their stories, the ones they couldn't help repeating, and their jokes the same. Look for a while into the darkness. Say their names. Listen and be still. But do not expect them to answer, if anything, in the hushed whisper of blowing leaves, just this: it's your world now. We did what we could. The living are the only architects of the world to come. Thank you for coming so much tonight and for joining us. I hope we will all be architects of the world to come, including making good use of prescribed burning and ancient wisdom about fire and our forest. Thank you so much, Professor Stevens, for joining us. And to all of you who joined us this evening, a very good evening, a happy All Souls, and a celebration of Samhain.
Thanks for the questions. I appreciate the questions.
Good night, everyone.